Hey guys, welcome to another video. We're going to be talking about watts, volts, and amps and what that means for you as a lighting tech. It's our job as lighting techs to kind of know how many lights we can put on a circuit safely without blowing, hopefully not fuses, but just tripping breakers. Um, Knowing if we're given this is how much power is at the venue, is now knowing, okay, so how many lights, what lights, and how many of them can I put on circuits or on different outlets. So let's just go through some definitions because watts, volts, and amps are all ways to measure different aspects of electricity. So when we look at watts, we're measuring the consumption, the power consumption of a device or the available consumption of like a wall outlet. The volts is measured is the measurement of potential power, and then the amps is the measurement of the current strength, how much of it can deliver. So the easiest way, if you're following along on the slideshow, I'm just on slide 3 right now. We're going to look at a pretty practical definition, the idea of electricity as a water pipe and a water tank. So the voltage measures the volts, and this is the potential power. So let's think of it as a water tank. That will always stay, hopefully, around the same amount. It will fluctuate depending on who's on the grid, what else is being drawn. But in North America, we're usually looking between 110 and 120 volts coming out of a standard wall outlet. Then the current is measured in amps. So this is the strength. This is the current going through the pipe. It's the pressure of the water, the pressure of that water tank being delivered. Now these two things, the two properties create watts. Now this is the potential available power for consumption. So all this kind of sounds a little much right now, but we're going to break it down in a very simple formula, the one formula I think every lighting tech needs to know. This is the West Virginia formula, and it's called that because it's WVA. Watts equals volts times amps. So going back to the wall outlet, I'm going to kind of stick with the 110 idea. I always like to underestimate how much power I have, just in case, you have to throw one thing on or someone needs to charge their phone or what have you. You don't want the lights to turn off because someone's phone is dying. So let's do a little equation here. If you're looking at the slide, if we do 15 amps, is what's coming out of a standard wall outlet in North America at the 110, that gives you 1650 watts. And now if you look on the upper end of the 120 volts, we're going to get about 1800 watts. Now, let's start calculating here. If you go on the next slide, I have a picture of a Colorado 1 quad from Chauvet. It's a static LED RGB fixture. And on pretty much all fixtures, even conventionals, it will tell you the wattage it takes. If you look at like older Lecos, you're maybe looking at the 575s or the 750s. Uh, and here it's on the side. And if you don't have it, if it's rubbed off or something, don't be afraid to Google. Google's your best friend. Almost every lighting manufacturer will have on their website every fixture they make with the technical specs. This includes the power. So if we look here, I pulled this right from Chauvet's website, and it tells you the voltages it can work on, which is 100, which I think is mostly Japan uses 100, and then up to the 240, which a lot of European countries use. It has auto range detecting, which is great. It also tells you the power link. So this almost takes the equation you don't even need to know. In this instant, it tells you you can do 15 units on a 120 volt system. Great. But what if it wasn't there? So if we look down here, it tells us it uses 109 watts, which is equivalent to 0.89 amps on the 120 volt system. So let's go to the next slide and we're going to start calculating. So we know that, like I said, minimum, hopefully we're getting the 1650 watts out of that outlet. So we take the watts we have, divide it by the watts the lights need, and that tells you how many fixtures you can put on that circuit. So even using the low estimate, we can put 15.13 of these lights on the circuit, and that's at like full stun. Uh, so the power link's correct here. We know that we did the equation, we double checked it, so we know that we should be able to put 15 lights on here. And this goes for any light, any object you know the wattage it takes. If you go down, there's a quiz. The quiz just kind of goes over and it helps you kind of really understand what I just talked about. And there's also a little survey at the end that you can give a little bit of feedback, or you can drop something down in the comments if you'd like. Thanks so much, guys, for listening. I'll see you next time.